Hi, I'm Chris Brown, and this is the second module in the second section on axiomatic design. This is the intermediate section, and I'm going to be talking now about FRs, theme selection, and see-me-min. So first, the importance of FRs. No design can be better than its FRs. The FRs define essentially the design goals. And fulfilling FRs is the definition of success in design. FRs are the things that need to be controllable and adjustable in the design. FRs require physical design solutions, the DPs. So FR formulation. How do we formulate the FRs? Well, the FRs need to translate the customer needs into engineering terms. They have to be capable of having performance or functional tolerances. We need to create them in a solution-neutral environment. Don't jump the gun on selecting the DPs. Don't limit the design space with the FRs. So the FR should be about functions and should work in the functional domain and save the physical for later. One of the things we need to realize is that formulating good FRs takes time and adds value to the design. Formulating good FRs historically is overlooked because so often engineers like to go quickly to find the solution, to get something on a blueprint. You need to describe where it is you're trying to go. Otherwise, you won't know when you get there. Formulating good FRs saves lots of time later on in the design process. If you can build a consensus on the design team about where the design is trying to go, everybody is paddling in the same direction or pulling in the same direction. All right, importance of FRs. They're the design objectives. As I said, they define success. They document the design intent. And without knowing the design intent, nothing really can be safely changed in a design. So these are, as we said, the independently controllable functions that describe what the design must do. A design can be no better than the FRs. High-level FRs and DPs require care. FR0 defines the direction, sets the theme. As I was saying, plan on investing some time at the top of the hierarchy with the upper-level FRs. Recognize the value of good upper levels in the hierarchy and be prepared to invest the time. So FRs define the directions, set the theme, provide value. Now the higher level DPs constrain the lower levels. So to get started, we could use some generic placeholders, terms like system, device, mechanism, and later add adjectives as appropriate, like a hydraulic system or pneumatic system or electrical system. So FRs should begin with verbs, be imperative in form, like a command. For example, limit motion to X direction, transmit loads, provide stability, create features, transform microstructure, for example, in a heat treatment, apply force. Now the FRs must be collectively exhaustive. Means we need to make sure we've included everything. Mutually exclusive, so the FRs themselves are not coupled, and we'll look at the consequences of that in one of the later lectures. And we want a minimum number of independent items, or a minimum number of FRs at each level that completely describe what the design needs to do. So at each level of the decomposition hierarchy, the children must be collectively exhaustive, mutually exclusive, and minimum number for decomposing the parents. See-me-min. All right, so there are different kinds of themes we might use for doing a decomposition. How do we know we're collectively exhaustive? Well, we can look at temporal, spatial, energetic, and component decompositions, as well as other. And we'll take a closer look at some of these later. The nice thing about including other in a list is that it automatically seems to be collectively exhaustive. But the problem still is going to be determining what the others might be. So some people seem to develop some kind of designer's block, similar to writer's block, when they're trying to develop FRs. And so to get unstuck, pick a theme, perhaps from a suggested list. Develop your own suggested list. We just took a look at one. If that doesn't work, switch themes and try again. If lower level themes work better, promote to top level themes. Themes can help ensure that that a design is see-me-min, or that a decomposition is see-me-min. And logical decompositions can be more evident with certain themes. For example, all right, so if we choose temporal, so here what we need to do is cover all times and only once. Spatial, if we do spatial decomposition, make sure we've essentially filled or considered the entire space and only once. Energetic decomposition. So there's really a couple of kinds of things we might do with energetic. One is consider all the energy types for certain kinds of problems. And another would be to follow the energy, since we can see how it is transformed and where it goes or where it does work. So themes and their components. So in spatial, we might take a look at Cartesian or cylindrical coordinates. In energy, we could take a look at different kinds: mechanical, thermal, electrical, electromagnetic. Some of the themes in mechanical design: position. Maybe we need to fix positions or transmit displacements. Load transmission. So maybe we have to get loads from one location to another. And motion control. Maybe we need to restrict motion in certain ways. So here was an interesting decomposition that we worked on. Namsu put a group together to work on crew survivability for the next orbital space plane, which we didn't end up building, but we spent some time trying to ensure crew survivability. And we looked at two ways of doing the decomposition. I was a proponent for doing an energetic kind of decomposition, considering then all of the ways that energy might do work on the crew that would somehow be unhealthy for them. Su recommended a temporal kind of decomposition, so protect the crew on the launch pad, protect them during launch, and so forth. So first, what is enough energy to injure people? And then as we combined these two, it seemed to make sense to do the temporal decomposition first, because certain kinds of solutions are available when it's on the launch pad. For example, just getting the crew out of the vehicle. That are not advisable in orbit, so because the environment in orbit obviously won't support them. So and there's certain kinds of energy that are more important at certain times than others. So we did it first temporally. We did first a temporal decomposition, protect the crew on the launch pad, and then an energetic decomposition, protect them from excessive heat, for example. So here we go. Protect the crew prior to liftoff, protect the crew during the launch, protect the crew during orbit. So this was the temporal decomposition. And then the energetic was protect the crew from thermal hazards or from acceleration hazards or from pressure hazards. So, as I was saying, the solution was to use both, one after the other. So protect the crew during liftoff, for example, then protect them from thermal hazards, acceleration hazards, and pressure hazards during liftoff. Is that collectively exhaustive? Are there other ones that we have to be concerned about? Here's another one for load transmission. And so here we'll use a Cartesian theme. So in this case, we're looking at transmitting loads between a boot and a ski binding. So these are, for example, control loads that we're trying to transmit. And so these are transmitted across certain boot binding interfaces. So the upper level, FR1, is transmit forces, and FR2 is transmit moments. And so in both cases, there's interfaces or structures for transmitting these. The moment definitely needs a structure because you need a lever arm and a force, like this, R cross F. So if we consider this, then, the further decomposition of transmit moments decomposes into provide lever arm and then transmit forces. Now I should note that provide lever arm is a weak FR because it contains physical information. So that should probably be reworded. So take a critical look at that and see if you can think of a better way to do that. Now, one of the things is we look for minimum number. We note that in the moment transmission, there's a transmit forces. And this is very similar, of course, to transmit forces in the load part in FR1. So if we transmit the forces here for the couples, for the transmitting the moments, then that seems to take care of it. So if we apply the principle of minimum number, then we can eliminate FR1 and its children because they're covered in FR2. All right, so let's see what this looks like. Now, this is not a current ski binding or boot, but so load transmission, Cartesian decomposition. So we're looking at transmitting moments about the x-axis. Let's take this along the longitudinal axis of the ski. So this would be the roll axis like you would use for edging. And then transmit about the y-axis. This would be a vertical axis perpendicular to the surface of the ski. And this might be for steering the skis and changing direction. And then the z-axis, around the z-axis, this might be for pressuring the tip or the tail of the ski for doing certain kinds of maneuvers. Now, with this free heel, as is indicated here, it's going to be a little bit more difficult to transmit forces in that direction because we've got a rather loose hinge there, and hence some of the binding designs from about 60 years ago or more, as there were efforts to attach the heel more firmly to the ski for transmitting these Z moments, which now is done much more effectively than it was then. Let's look at a decomposition, another example for shop safety. So themes spatial versus energetic. So if we take a look at, say, spatial, we need to protect users from injury, and we could say, let's protect them at machine X, for example. Or we could say, let's protect them from energy type Y. And then at machine X, we could then do the energy decomposition, or after doing the energy decomposition, we could say, let's protect them at certain machines. The path really doesn't matter so much, although some paths may be easier to follow than others. And so look out for that. I think it's probably easier to first protect the machines and then look at the energy types, just as it was easier for the space shuttle to first consider the time, first consider the time, and then within the time consider all the kinds of energy. So we could say the solutions are equivalent if when we get down to the leaf level, we're looking at things like safety glasses, ear protection, gloves, eye protection. So at that point, the solutions really become equivalent. And so this is, so it doesn't really matter which order we do this in unless one is easier to implement. And so I think it may be easier to implement first the spatial and then the energetic. but that's my personal preference. All right, so what about the minimum number of FRs? Let's take another look example of this. I was doing some consulting work at a company that made batteries, and they asked me if axiomatic design could come up with a good design solution that they had come up with without using axiomatic design. And so the idea was to prevent batteries from exploding. And so the theme is energy. And so the idea, let's prevent them from exploding due to chemical energy. Let's prevent them from exploding due to electrical energy. Let's prevent them from exploding due to temperature rise. So the idea was, as I was developing the solution, is that I needed a collectively exhaustive look at all of the things that might cause the battery to explode, and then prevent explosion due to pressure. And so I was imagining different sensors for these that would then signal something to disconnect the battery before it actually exploded, so it stopped getting energy from the external environment. So now, as you consider this, why does anything explode? It explodes because there's a pressure differential. So therefore, we don't need FR1, 2, and 3. All we need to do to keep it from exploding is monitor the pressure. So mutually exclusive FRs. So sometimes the language can clearly indicate the mutually exclusive aspect of the decomposition. And there are better and worse ways of wording it. For example, if FR1 is provide good adjustment feel for a steering column and FR2 is minimize deflection when lost, it's hard to tell if these are mutually exclusive. However, if we say instead provide axial adjustment feel and control radial stiffness, then we can see that we're working with cylindrical coordinates, and in this particular case, it appears that they are mutually exclusive and perhaps collectively exhaustive as well. So by using the underlying words, the orthogonality in the decomposition is indicated. And this will often directly lead to mutually exclusive. Orthogonality. That's another way of saying they're mutually exclusive, so that if I move along one axis, there's no motion on a perpendicular axis. So they're orthogonal. Thank you for your attention.